Hi, welcome. Thank you so much for joining us here today on this WiCyS webinar, also with AWS. We're super pleased to have Enya and Swati here from AWS presenting on If It Moves, Log It. My name is Lynn Dome, Women in Cybersecurity Executive Director. We often go by our acronym WiCyS, W-I-C-Y-S, pronounced WiCyS like we sisters, because that's exactly what we are. We are a cyber sisterhood. And our mission is to recruit, retain, and advance women in cybersecurity. We're a community comprised of men, women, allies, and advocates that all have a strong mission and passion to recruit and advance women in cyber specifically. And so we have representation in over 70 countries. We have 45 professional affiliates in Africa, Australia, Canada, France, India, Pakistan, the UK, and all throughout the United States. In addition to that, we also have over 160 student chapters. We do so and do all of this by creating opportunities for our community members. So we're an online member forum where all our members can network and connect. We have skill development training programs brought to us by Google, AWS, Microsoft, and all our supporters, and so many other initiatives that they support as well. We have a newsletter and webinar series. We offer scholarship grants and awards not only to our conference, which will be March 16th through the 18th in Denver, Colorado in 2023, but also to other conferences as well. We have a cyber talent emergency fund for cybersecurity students to receive up to $599 within 48 hours if they have a true financial emergency, like they need medical assistance or their car breaks down. We don't want anything from our student members to derail them from their cybersecurity studies. We provide speaking and media opportunities for our members to be what others can see, and that's the cybersecurity professionals that they are. We have the Job Board Plus Plus that our strategic partners like AWS recruit from year round, and all our members can upload their resumes and have access to that too. We have internships, apprenticeships, participate in market research, have leadership series, leadership summits, leadership workshops. We offer military and veteran assistance programs. We also have a speakers bureau and a mentor-mentee program, all this and so much more. So if you haven't done so already, please check us out at WiCyS.org. We owe all this as a special thanks to our strategic partners, AWS, that brings us the webinar here today, Bloomberg, Carnegie Mellon Software Engineering Institute, Cisco, Fortinet, Google, Intel, Lockheed Martin, Meta, Microsoft, Optum, Sandia National Labs, SentinelOne, AbbVie, JP Morgan, Chase & Company, LinkedIn, McKesson, Navy Federal Credit Union, Nike, Wayfair, Workday, and all our Tier 3 partners as well. So before we kick off this webinar, I just want to remind everyone that we are so lucky to have Swati and Enya here today to be able to answer all the questions that you might have. So at the bottom of your screen, you have that chat function for you to enter your questions, and they'll be answering them live at the end of their webinar. And if you haven't done so already, please subscribe to the WiCyS newsletter to stay up to date on all our events, initiatives, and programming. So without further ado, I'm going to hand it on over to Enya to take it from here.
Thank you, Lynn. Thank you to WiCyS for giving us this opportunity to present on AWS logging and monitoring. If it moves, log it. My name is Ina Salmon. I'm a senior security consultant with AWS Professional Services, helping our customers to build on AWS securely. Prior to joining AWS, I've been involved with various aspects of cybersecurity, such as vulnerability management, endpoint and network security, data protection, encryption, and cloud security. I'm joined today by my colleague, Swati Priya. Swati, please introduce yourself.
Hey everyone, I'm Swati. I'm an associate security assurance consultant with AWS. I've been here for a little over a year and a half, and I've been in the cybersecurity space working with other big fours in the past for around 6 years now.
Today, we are going to talk about cloud monitoring challenges and the opportunities that we could provide with AWS native services to monitor and collect logs on AWS. Why cloud monitoring? and why cloud monitoring challenges? Well, there are quite a few. First of all, cloud presents an opportunity to collect a tremendous volume of the events, and you have a tremendous volume of data sources that could produce logging in the cloud. Identifying important issues is often challenging. Did you know that an average security analyst spends 60 to 70% of their time sifting through non-critical events, trying to see what's important and what could be ignored? Recurring problems are also challenging to analyze and understand. Are those really symptoms of an issue, of underlying issue? Are those indication of compromise, or just something that hasn't been fixed? Analyzing and investigating security events with modern applications, it's a complex job. Custom applications often run in distributed environment, in hybrid architectures, have containers and microservices. So why monitoring is important? Monitoring at AWS gives you that visibility, or we call it at AWS observability, into your cloud resources and applications that you've deployed. Best practice security recommendation is to enable native cloud logs and harness native cloud power to collect those logs. Often you would also deploy security agents that will be on your cloud hosts, your cloud VMs at AWS, those are EC2 instances that will provide you those additional host level, OS level application logs. With those logs, you would want to produce metrics and traces that would help you diagnose any issues with your application, be it performance or security related. With traces, you could troubleshoot. You would also want to categorize and collect events and create some kind of an alerting mechanism that would help you automate your response if something goes wrong with your application. You would also want to create dashboards so that you could analyze those key performance indicators and security posture of your application, and also present it as to other teams. And you would want to create alarms so that you could engage your security and cloud operations personnel to respond to any kind of security or performance issue with your application in a timely manner. Traditional security monitoring on-prem follows broad and shallow approach, where you try to collect as much logs as possible, and you have really limited number of generic use cases which often don't cover your whole security posture. It's very often that if security analyst operates in a silo, he or she will not see deep insights into the application and really understand what is business as usual or what is real a security event that requires deep investigation. More so in the cloud native environment, where perimeter of your workload is not just your network edge, but it's also identity and access management and specifics of your virtual private cloud or VPC. Malicious behavior within your workload is very often hard to recognize because those malicious actors would use living off the land techniques and APIs that only somebody with a deep knowledge of your application know to detect anomalies. And that's where it's very important to engage application owners and architects in investigating security events and have threat models and network diagrams and data flow diagrams that would give you that insight into the application so that you could detect that anomaly and that anti-pattern and identify if it's really a security event. You would also want to shift left and identify security issues in the infrastructure as a code before you even deploy it in the environment. You would want to shift from that centralized security management to distributed security management, where you could enable your application owners to partner with you to protect the applications with preventative guardrails, detective controls, and self-service security. A combination of both approaches, broad and shallow, and deep and narrow, is what is required to make cloud security operations a success. Managing security in the cloud and at AWS follows the same model and the same towers of security as your on-prem environment. We call those security epics, such as identity and access management. What roles and privileges do you have to access your environment, your accounts, your applications? Detective controls, which are logging and monitoring, and detective guardrails in your environment. Infrastructure protection, protecting your virtual private cloud and protecting the edge of the application. Data protection, which focuses on data classification, tokenization, masking, data encryption, and managing those encryption keys, as well as managing secrets. How does your application talk to the database? How do you exchange those credentials securely? And incident response, understanding what is deployed in your environment, how you could protect it, and how can you automate the response. If it moves, log it. If there are changes in your AWS environment, you would want to see it in the logs. There are different log categories that you could collect, such as AWS infrastructure logs. Those are AWS Cloud Trail logs, which are any API calls that you make on AWS. AWS config logs give you the logs about configuration of the resources and relationship between those configurations. Amazon VPC flow logs, those are your network logs in your virtual private cloud environment. And CloudWatch logs that could aggregate logs from many other different sources and give you the capability to analyze it at scale and over time, and also create insights, metrics, events, and alerting. Almost every AWS service produces their own access logs, such as Amazon S3 access logs, Lambda logs, AWS Elastic Load Balancing logs, CloudFront logs. There are over 200 AWS services. I definitely cannot list them all here. And host-based logs, such as operation system logs and application logs and container logs. To get those logs, you would need to deploy additional agents, such as AWS CloudWatch agent, which you would deploy to EC2 instance and configure. Sometimes you would need to install additional drivers to get that deep information from the operating system, from the containers, from the applications, such as also event logs, messages, security and audit logs, as well as performance counters. Let's dive deep into the foundation of logging in AWS, which is AWS Cloud Trail. Everything that you do on AWS is via API calls. Whether you log in through AWS Management Console, through the command line interface, or programmatically through the software development kits, Terraform, CloudFormation, all of it are via API calls, and those are collected in AWS Cloud Trail. Based on those in Cloud Trail, you could categorize the events so that you could use them for troubleshooting and investigation, for identity and access management changes in your account, in your application, get visibility into the API calls with which resources have been created, changed, or terminated, and any kind of changes in your network of your virtual private cloud or VPC. Security best recommendations is to enable AWS Cloud Trail in every account and all regions, even in those regions where your application doesn't have any business need to run. You might ask why. And the answer for this is that if there is any kind of malicious activity in a region where you don't have authorized resources deployed, you want to have that visibility. And that's what CloudTrail can provide to you if you enable CloudTrail everywhere. Here's a snippet of a CloudTrail log in JSON format, which is a native format for CloudTrail logs. it can give you that who, when, what, where, and with which parameters information. It doesn't give you an information on why something has happened. For that, you might need to use something like third-party tool, like your security incident and event management tool, or SIEM, to give that correlation analysis and build up those use cases. So let's dive deep. When you log into AWS and perform any kind of API call, CloudTrail will detect it and will give you that who information, whether you logged in as IAM user with permanent credentials or the preferred way, logging in with SSO or IAM user role with those temporary credentials, it will show up in CloudTrail and give you that user information. It will also give you the account information and the access keys. Now, if you log in as a user, as a privileged user with something like permanent access keys, it will be displayed here. If you log in through the SSO or IAM role, user role with temporary credentials, then a temporary access key is being issued. And why we call it a preferred way is because those temporary user roles rotate those access keys with a predefined time window that you would define when you create those SSO or IAM roles. CloudTrail logs give you when information. It gives you this timestamp where that action or that API call has been made in server log time in UTC. It will give you where information, such as in which AWS region, here it's US West 2, and from which IP address a user has made that API call, and also a parameter with which that action has been produced. Another very important source of logging on AWS are VPC flow logs, which gives you the snippet in time on the network activity. You could enable VPC flow logs for the whole VPC, for the specific subnets, or for specific instances, or even elastic network interface on a specific instance. VPC flow logs come with some default fields that will answer you in which AWS account that network activity has been performed, on which interface IP that network activity has been detected, source and destination IP, source and destination port, protocol, packets, bytes, start and end time, and if that traffic was accepted or rejected, if it was successful or not. You could also enable custom fields for the VPC flow logs to give you that additional information, such as instance, VPC, and subnet ID, depending on where that VPC flow log is enabled, TCP flags, as well as packet source and destination address, which could come in handy when you're troubleshooting traffic where load balancers are involved or network address translation is involved. CloudWatch is a very important logging capability on AWS because most of the native logging capabilities of AWS services are natively integrated with CloudWatch. A good example of it is CloudTrail and VPC flow logs are natively integrated with CloudWatch. I would say most, but not all of the AWS services send their logs into the CloudWatch by default, but that's something that could be configured. You would configure log streams and log groups into the CloudWatch, and that's what gives you that capability for you to analyze logs at scale over a specific window, be it 30 minutes or months, produce insights such as log insights, container insights, application insights with SQL-like queries, create matrix on memory and CPU utilization, create CloudWatch or EventBridge events that you could lift from your service logs or from your host logs if you deployed CloudWatch agents, such as var log messages or var log secure logs, so that you could get that deep insight into the application system and application level logging. Let's walk through the scenario of how you could create a metric alarm or an event breach alarm alert based on CloudWatch logs. So let's look at the bullet number 1. A user makes an unauthorized IAM change, be it a malicious user or maybe it's accidental change. Now everything on AWS is done through the API calls, which are being logged through AWS Cloud Trail. Now looking at bullet number 2, CloudTrail logs could be collected in S3 buckets, which are object-level storage on AWS, and then you could analyze those logs in S3 buckets, either with AWS-native capabilities, we are going to cover them in the following slides, or integrate with third-party SIEM tool to analyze and query logs from those buckets. CloudTrail also is natively integrated with CloudWatch logs, where it sends the logs into the log groups. And you could produce metric filters from those logs, or you could create event triggers and create alerts, which you could enable simple notification service. That's an AWS native service that natively integrates with CloudWatch alarms or event triggers to create alerts. Your security admins or your cloud operations team can subscribe to that simple notification service with whatever endpoint makes sense to them, be it email, Slack channel, Teams notification, or third-party ticketing tools such as PagerDuty. And that, with this whole cycle, seamlessly get notifications and react to the event. Processing logs in AWS could be done in with various tooling. As mentioned before, CloudWatch log insights allow you for that near real-time aggregate monitoring and query-like searching with the logs right in that AWS environment. You don't need to go far. That's where you could process your logs for that specific account that you are at and for that specific region. You could also utilize Amazon OpenSearch, formerly Elasticsearch, or Elk Stack, which integrates with Kibana interface, for additional analytics, some of the pre-built use cases, and visualization of your logs. You could use AWS Lambda and Amazon Kinesis integration if you need to filter your logs, pre-process logs to make them, to transfer them into specific format, or add additional information to your logs before you send them to a third-party SIEM tool. You could also export logs into S3 bucket and leverage Amazon Athena with SQL-like queries or QuickSight for visualization, and you analyze your logs at scale, and also if you use that with AWS organizations over multiple accounts.
AWS also integrates with different partner solutions for processing logs. So what is the difference between log monitoring and analysis? Log monitoring is the process of collecting information and identifying and alerting about any issue that's involved, while log analysis is the process of evaluating that information and remediating that issue. AWS also has a marketplace, which is an online software store, which our customers leverage to download softwares and solutions that run on AWS. And one of the most recent examples that we have seen our customers use is Splunk.
Another source for security alerting on AWS is using AWS Trusted Advisor. Trusted Advisor is that well-architected tool that could look into the different well-architected towers, how your application is deployed, and give you analysis on cost optimization, performance, security posture, and fault tolerance. It comes with some predefined checks. The number of those checks depends on the support plans that you have with AWS. where basic support plan comes with initial set of checks, and you have expanded set of checks with enterprise or premium support. You could send those security checks and results of those checks as alerts for your cloud or for your cloud security or cloud operations team. You could create scheduled reports that would look at your security posture in a specific account, specific region, or across the whole AWS organizations if you enable Trusted Advisor for AWS organizations. And it could give you information on what kind of open ports you have, if you have unrestricted access to your application. It could give you checks based on CloudTrail logging and some of the critical events from that CloudTrail. It could give you information whether your S3 buckets have public access, information on DNS records, load balancing configuration, and if you adhere to your password policy, among many other checks. Now, with all of those logging opportunities, some of our customers ask us, well, we're new to AWS and we don't have capacity or know-how to collect and analyze all of those logs to determine if there are any threats in the environment. Do you have any kind of tool that maybe has artificial intelligence that would look at all of those logs and produce findings and alerting for us? And with that, I'm passing on to Swati to present you Guard Duty.
Thanks, Anna. So threats. Who doesn't like threats? Just kidding. Nobody wants to wake up to a compromised EC2 instance, and that's why we have Guard Duty. Guard Duty is a threat detection service that uses machine learning, anomaly detection, and integrated threat intelligence to identify threats and prioritize them. It automatically and continuously monitors the AWS workloads and resources for potential threats in your environment. And it is capable of analyzing tens of billions of events occurring from different data sources, such as VPC flow logs, DNS query logs, CloudTrail events logs, S3 data plane logs, and the most recent one is the EKS control plane logs. So one interesting fact about Guard Duty is that even if you don't enable these logs in the background, it uses the backbone of AWS to come up with findings related to these logs. Uh, Guard Duty findings are categorized as low, medium, and high, depending on the severity of the issue. So here's an example of a Guard Duty finding, and as you can see that there's an attempt of a brute force attack on a particular EC2 instance. There are two scenarios in this situation. The first scenario being, say somebody in your organization is attempting penetration testing on that EC2 instance. In that case, the originating IP address is a known IP address. What you can do in this case, if it comes as a finding on Guard Duty dashboard, you can choose to manually archive it, or you can create a suppression rule and add this particular IP address as well as this EC2 instance ID so that it automatically archives this finding and also archive such type of findings in future. Coming to the second scenario where the IP address is not known. What happens in this case? Well, it could be a malicious activity and requires further investigation. Guard Duty has several ways of investigating different types of finding, and most recently, it has introduced the use of detective. What detective does is collects and aggregates security logs and extracts security information and creates visualizations for you to easily understand and quickly remediate any issues in your environment. Another new feature introduced within Guard Duty is the Kubernetes audit log monitoring to identify any malicious activity and misconfigurations that may result in unauthorized access to your EKS clusters. Uh, One another benefit with having Guard Duty is that you can monitor all the AWS accounts with just few clicks on the console and without having to download any software. And if you would like to explore Guard Duty more, you can do so by creating a Guard Duty findings simulator by just generating some sample findings on the dashboard. So one of our customers asked if we can create a dashboard for security, and we said yes, absolutely, you can do that with the help of Security Hub. So, what is Security Hub? Security Hub gives you a comprehensive view of different alerts and findings originating from different security services like Guard Duty, Macy, Inspector, Firewall Manager, IAM Access Analyzers, and even integrated partner solutions. It conducts automated security checks in your environment with the help of different compliance standards that are inbuilt within Security Hub. So currently there are three compliance standards, which are AWS Foundational Security Best Practices, CIS AWS Foundations Benchmark, and PCI DSS. These standards are based on the regulatory requirements and also best industry practices. And customers can choose to enable or disable these as needed in their environments. This is an example of a dashboard for CIS AWS Foundations benchmark, and these are the examples of findings. So as you can see, there's one critical finding, and which says that we must avoid the use of a root account for any type of access. And there are other medium level findings which are more IAM related. For example, probably MFA is not enabled on some of the IAM users for logging in, or there are password policies that are not stringent enough and do not have an uppercase or a lowercase within them. Another cool feature with Security Hub is that you can create your own dashboard as well. So currently there are 20 pre-built insights, but you can create your own according to your needs. So what is an insight? It's nothing but just grouping different types of findings based on the product it is originating from. For example, you can create your own insight related to EC2 instances that have missing security patches, or probably create an insight for S3 buckets with public read and write permissions. What it does is gives you a better visualization for better assessment, and it saves time and helps you quickly remediate and mitigate issues. So there are some findings which require immediate action, and organizations are not willing to waste that time of going to the dashboard of Security Hub and looking for alerts and findings. What can you do in that case? What we can do is create a custom action in Security Hub and alert the security team or the individual via email, Slack, or send an email to the security team directly if any urgency happens in your environment. You can also choose to conduct incident response by auto remediation, by isolating or terminating any instance related to any type of finding. And with that, I will pass it on to Ina again.
A lot of times we are asked, well, it's difficult to protect workloads on AWS or in cloud in general because there is often not enough visibility of what's deployed out there. And with that, AWS Config could help because it gives you both inventory and configuration information of your resources and answers those questions, such as what is currently out there, if it's in running or stopped state, what is the latest configuration on your resources, and relationship which exists between those configurations. If there are any kind of issue with the application of workload, you might ask what has changed. And that's what AWS Config can give you information about configuration changes that occurred in the past and the current state. Also, AWS Config uses config rules that can give you compliance posture of specific resources or your application. You could use AWS Config Advanced queries to get specific information from your resources, such as you could ask how many EC2 instances are running in my account. By the way, you could also, if you run AWS Config in your AWS organizations where you have multiple accounts, you could create aggregators that work with AWS Config and use advanced queries to get this information across the whole region, across multiple accounts, or a single account in a single region. A good example of that, if you need to find EC2 instances with specific application ID tag. AWS Config can give you information on when a resource become non-compliant according to a specific rule, and give you that resource timeline with a specific timestamp when the resource came out of compliance, and tie it to the specific API call that will in turn give you that who, when, what, and with which parameters information. And now that you've detected that the resource became non-compliant and is not performing the way you expected, you could get that window, that plane of view of what has changed, that before and after picture. So in this case, an EC2 instance was in the running state, and then it was stopped with an API call. And in this configuration change, you have information from which IP this action has been produced, and also tied to additional information for investigation. AWS Config runs a number of security and compliance checks. It's called AWS Config rules. And you could integrate those with automation through CloudWatch event alerting, through EventBridge alerting, and also tie it with security dashboards. You could integrate it with your third-party SIEM tool to get alerting on, for example, data loss prevention, or any kind of detective controls that would indicate some kind of malicious activity or compromise. Example of the config rules for data loss prevention is to see if any of your data stores might become public, such as, for example, if S3 bucket has public access. In this case, the change on that rule would indicate non-compliance, and based on that, you could trigger an alert. Another example is to use ACM, which is AWS Certificate Management check, to alert you on any kind of certificate expiration, like TLS certificate expiration. Similar to the Security Hub, AWS Config could also harness auto-remediation capabilities. So in this case, we would non-compliant due to one of the security checks that pertain to EC2 instance. You could create a rule that will integrate AWS Config with systems managers that could run automation, or with Lambda, which is a serverless compute node that could run automation code in, let's say, Python or Java or any other language with which Lambda could be integrated. And you could trigger that remediation action. It could be done either manually by pressing remediation button in the console, or it could be set up to run automatically and bring your EC2 instance into compliance. Very often our customers ask us that when they run a distributed environment, or when they run a multi-account structure using AWS organizations, what are the best practices on creating security monitoring and security logging in their multi-account environment? AWS has prescriptive guidance called Security Reference Architecture that will walk you through step by step on enabling delegate administration of the security tools, such as GuardDuty and Security Hub, And there are other native AWS security tools such as Macy, which is data classification tool, and IAM Access Analyzer. You could set it up so that your security team would operate in a security tooling account that would work as a hub-spoke model. And from that security tooling account, the security team will be able to configure those tools in other accounts, as well as get the visibility of what's happening in other accounts, the findings of those tools from other accounts without logging into those member accounts. All of this visibility could be done through that security tooling account that is set up as delegate administrator for the security tools. Security reference architecture also gives you prescriptive guidance on how to centralize logging into the log archive account, that read-only account from which security team then could either analyze logs natively on AWS or integrate with third-party SIEM tools. As mentioned before, when you investigate anomalies for the security events, it's very important to create use cases that will cover broad and deep behavior of your workloads on AWS. You would want to protect databases from reconnaissance attack and data exfiltrations, as well as any kind of data storage in the cloud. You would want to protect your compute nodes from malicious execution, of any kind of malicious code. And you want to protect your access to the accounts and applications from privilege escalation and intrusion. An example of reconnaissance attack on databases might be a SQL query such as show tables that is unlikely to be run in your environment. Or for example, all of a sudden your S3 bucket might become publicly accessible, which will be an indication of data exfiltration. So creating those use cases very often requires collaboration with your application owners and architects. To summarize security on AWS and logging and monitoring recommendations, turn on AWS native logging capabilities in each account. If you're using AWS organizations, your multi-account structure, set up logging and monitoring according to the security reference architecture, or SRA. Centralize log shipment and set up alerting, whether it's through AWS native alerting with CloudWatch and simple notification service, or via your third-party integrations. At a minimum, enable Amazon GuardDuty and AWS Security Hub, but also look into other AWS native security tooling. Integrate logs, GuardDuty, and Security Hub into your third-party SIEM, such as which is Security Incidents and Event Management tool. Set up ability to query logs either natively on AWS or in SIEM, and a lot of customers do both, depending on the use case coverage. Security automation for detection, auto-remediation, and incident response is the maturity state that is paramount to the cloud environment and allows you for that fast response and scalability. Security is everyone's job, and workload-centric security management and incident response requires close interaction and knowledge of your applications. That's where threat models and resource tagging, network and data flow diagrams are very important, as well as streamlining ticketing so that you could streamline that communication between cloud security team, cloud operations team, and workload owners. Thank you very much for letting us present on logging and monitoring at AWS. And now we're open for questions and answers. And let me. All right, so I see already one of the questions in the environment. Should security be provided primarily on the VPC or on the EC2 instance? I'll take that one. I often look at the security as that layered onion approach, where you need to provide and enable security at every layer. So I would say not just on VPC, not just on the EC2 instance, at the edge, on the host, and on the application running in the EC2 instance. So when we say, for example, guard duty could be used for threat detection, that's where threat detection occurs on the VPC level. That doesn't say that you don't need to have host-based detection mechanisms to identify threats that pertain to your application or operating system. All right, let's see if there are any other questions. Another question that we often get, are AWS native tools regional, and can they satisfy, for example, GDPR requirements? Swati, I know you have some experience with that. Would you like to take that one?
Mm-hmm. Yep. So for example, like CloudTrail or GuardDuty, these are regional services. And for CloudTrail, for example, we often are asked, how long can we store information in a particular CloudTrail? And so the answer to that question is that it can be stored for 90 days and in the CloudTrail event history. And all these services are regional. And if you want to enable these services in different regions for your environment, you would have to go and change the region and go ahead and enable it in each and every one of them.
Yeah. To add to that, most of the AWS security tools, such as GuardDuty and Security Hub and Macie, are GDPR eligible and regional. And with that, what it means, GDPR eligible, is that you need to create configurations such as encryption and identity and access management into every region that would satisfy your regulatory requirements that might have regional requirements such as GDPR.
Mm-hmm. Another question that we are commonly asked, is the difference between GuardDuty and Macie. So GuardDuty is a threat detection service, and it analyzes your AWS accounts and different workloads, and it identifies threats. While Macie is used to discover and protect your sensitive data in S3 by classifying what data you have. Say, for example, you have any keys, any KMS key stored in S3, Amazon Macie would be able to identify that and report it, and then you can take actions at your end.
Another question, you've provided reference to security reference architecture for which probably is used for enterprise level big companies that run this multi-account environment. What kind of security best practice reference can you give for a small startup with running in one account, let's say? So recommendations for that, we have another prescriptive guidance for specifically for startup security baseline. And it has many common grounds with security reference architecture on protecting your account access, encryption, and network. The difference is that security reference architecture also gives you more information on what could be done if you have control tower and AWS organizations enabled to govern those that multi-account architecture and enable preventative and detective guardrails in control tower, and also enable centralization of monitoring and logging in AWS organizations.
All right. Another question is around how are AWS config and config rules related to Security Hub? I can take that one. The backbone of Security Hub is AWS config and config rules. So what config does is um, it it looks for any changes or differences in the configuration of your environment. Say, for example, you change the properties of your S3 bucket, or you change something related to your KMS keys. So these properties are the backbone of Security Hub. These are included in the Security Hub, and config rules become the primary mechanism to evaluate the configuration of AWS resources.
I'll take that last question. Uh, we are not getting support of enabling VPC flow logs and DNS logs in every account in our environment. Can we still use guard duty for threat detection? The answer is absolutely. And as Swati mentioned during her presentation, guard duty looks at the backbone of AWS to analyze CloudTrail, VPC flow logs, DNS query logs, and EKS audit logs, even if you don't enable them. Now, guard duty will produce finding, and you could create an alert of that finding. If you need to go and investigate and look at the actual log, that's where you would actually need to enable it in your environment. All right, thank you very much. Thank you for the opportunity to present on behalf of WiCyS and AWS. Thank you for your wonderful questions. With that, we will complete this presentation. Have a great day.
Thanks, everyone.
I also would like to mention that if you've registered for this presentation, then the recording of the presentation as well as the slides will be available on demand. Thank you very much.